Hi guys, this is our last section of BCal 1 and its derivatives of exponential functions. Okay, and so here's my rule. All right, so with derivatives, usually we multiply down and subtract one. Not true with exponential functions. If y is equal to e to a power, then the derivative of e to the power is e to the power times the derivative of the power. Okay? So if y is equal to e to the 5x squared plus 1, okay, then y prime is e to the 5x squared plus 1. The exponent on e never changes. We don't subtract 1, but we do multiply that by the derivative of the power. And the derivative of 5x squared plus 1 is 10x. And you can leave it just like that. You can put it in the front if you want to. And if by chance you have a constant in front of that y, 3e to the 6x plus 2, then your derivative is just bring the constant along, e to the 6x plus 2. And what's the derivative of 6x plus 2? 6. And you can leave it just like that. If you want to call it 18e to the 6x plus 2, you can, but you don't have to. You don't have to simplify. That's how Hawks would probably give you the answer. Okay, so let's look at the homework. There are not that many, and this is not that hard. And I'm sure Mr. Hunt explained everything in the lecture videos. This is just me working the homework problems live. Okay, so section 5.4, practice problems. Okay. All right, so y is negative 8x to the 4th plus e to the x. Okay, well, the derivative of a function plus a function, I just add the derivatives. So the derivative of negative 8x to the 4th is 8 times 4 is negative 32x cubed plus, now the derivative of e to the x, right? If you have e to a power, it's e, the derivative is e to the power, the exponent never changes, and you multiply it by the derivative of the power. So when we take the derivative of e to the x, it's e to the x times the derivative of x, which is 1. So you don't have to put the 1, I'm just showing you that I took the derivative of the power. Okay? All right, so number 2 is negative 3, a constant times e to a power. So the derivative is negative 3e to the 1/2 x to the 4th plus 7. The exponent on e never changes. We just have to multiply it by the derivative of 1/2 x to the 4th plus 7. So that's 4/2, which is 2x cubed. And make sure you put it in parentheses. And you can leave it like that on Hawks. You certainly can. You could multiply and call it negative 6x cubed e to the 1/2 x to the 4th plus 7. But you don't have to. Either one is fine. Okay. And then one more just like that. If f of x is 5e to a power, negative 5e to the power, then the derivative is negative 5e to the power times the derivative of 2x to the 5th plus 6, which is 10x to the 4th plus 0. Okay, and you can leave it like that. You certainly can, or if you wanted to multiply the outside numbers, you could call it negative 50x to the 4th e to the 2x to the 5th plus 6. Either one is fine. I usually just leave it like this because I don't simplify, because I'm kind of lazy, and sometimes you make mistakes when you simplify. So not so bad, right? Okay. All right, let's look at number 4. All right, so number 4 is 5x to the 4th times e to the x. Okay, before we had, what did we have? we have negative 8x to the fourth plus e to the x. So we took the derivative of this term plus the derivative of this term, which is always what we do when we add or subtract algebraic terms or any kind of terms. But when we multiply 5x to the fourth times e to the x, we have the multiplication of two terms, 5e to the fourth times e to the x. And so I have multiplication, so how do I take the derivative of two terms multiplied together? It's the product rule. Okay, so what is the product rule? 1d2 plus 2d1. So what is my first function? 5x to the fourth. What's the derivative of my first function? 20x cubed. What's my second function? E to the x. And what's the derivative of my second function? The derivative of e to the x is e to the x times 1. Okay, so when I plug it into my formula, I just say my first function, 5x to the fourth, times the derivative of the second, we'll just call that e to the x, plus the second function, just like it is, times the derivative of the first, 20x cubed. And I will just leave it just like that. Okay, product rule, because you had 5x to the fourth times e to the x. Two functions multiplied together and they both had x. Remember, this one was two functions of x, but they were added together, so we added the derivatives. When you multiply, you have to use the product rule. Okay, so now let's look at this one, number 5. Okay, here's my function and they want g prime of 2. So what does that mean? I'm going to take the derivative and plug in 2. Get my calculator. Okay, so g prime of x is negative 3e to the 6x cubed plus 9 times the derivative of 6x cubed plus 9, which is 18x squared. Okay, and so the thing about it, we've been doing 2, store for x and enter, and we just plug all that in, but they won't take that number. We have to leave it in terms of e. Okay, so let's do my outside number. So g prime of x is negative 3 times 18x squared is negative 54 x squared e to the 6x cubed plus 9. Okay, and so I ran out of room a little bit. Okay. Okay. Well, and I mean, you didn't have to do it that way if you didn't want it to, but g prime of 2 says I just go put into everywhere there's an x, okay? And if you want to do it here, you can do it here. G prime of 2 is negative 54 times 2 squared, and it's going to be e to the 6 times 2 cubed plus 9. They want you to leave it in terms of e. So my outside number is negative 54 times 2 squared, which is negative 216, e to the 6 times 2 cubed plus 9. So 57. It makes a huge number if you tried to put that into the calculator. It's second function ln e to the 57, and it would make a what's that, scientific notation, and the computer won't take it. So when you evaluate g prime of 2, when you evaluate the e, you're just going to leave it in terms of e. And honestly, if you took this first derivative that we took, negative 3e to the 6x cubed plus 9 times 18x squared. You didn't have to multiply that out. G prime of 2 would be negative 3e. 2 cubed is 8 times 6 is 54 plus 9. You still have to do that. 2 cubed, did I do that right? 6 times 2 cubed plus 9. Is 57 times 18 times 2 squared, 72. And you could leave it just like that. It doesn't matter. If you multiply 72 times negative 3, you'll get negative 216. Either of those is fine. Okay, remember when we plug in a number to the derivative, that really is giving us the slope. The slope of the line tangent to the curve. Okay. All right, but I wanted to show you, if you click, sometimes you know how it's random, but this is exactly the same problem. It's another version of number 5, but look how they ask for it. They say find the formula for y prime, so they want you to take the derivative and determine y prime when x is equal to 2. That is just another way of saying they want y prime at 2. Okay, so the first thing we would do is find y prime, which is negative 4e to the 7x cubed plus 4 times 21x squared. That's my derivative. And then y prime at 2 is negative 4e to the 2 cubed is 8 times 7 is 56 plus 4 is 60 times 21 times 4. So you could leave it like that. That's fine. Or if you wanted to multiply it out, negative 4 times 84 would give us negative 336 e to the 60. They're both exactly the same. Yep, you just have to remember to leave it in terms of e, and it doesn't matter about how you write your answer. So you're taking the derivative and plugging in that number. That's just a weird notation. Here, we're more used to this. G prime of 2 means find G prime and then plug in 2. Okay, I just wanted you to see that. Okay, and then let's see. That was 4, 5, and then here we are. Good. 1, 2, 3, 4, 5. There, that was all the problems. I'm making sure. Oh my goodness, that means we're done. That's stuff we already did. That's stuff we already did. I didn't forget anything. There were just 5 problems. So that's it. Congratulations. So that's all that. Look at my thing. That's all the practice problems for the rest of the semester. And so y'all need to be getting started. But let me know. I mean, it's easy to make mistakes. So if you work something that's not the same as mine, email me, take a picture, whatever, because I'll make mistakes. Okay. Good luck, and get started. Okay. All right. Bye.